Alright, you are welcome back to Introductory Mathematical Analysis. Alright, we are going to be taking this example. Given the function, we want to find the interval where the function is increasing and or decreasing. We want to find the relative maximum and minimum. We want to find the interval where the function is concave up or concave down, and then we want to find the point of inflection. Okay, so this is the function. So let's find, given the function, which is x equals to s squared minus 1. So now we need to find where the interval where the function is increasing or decreasing. In order to do so, we need the derivative first. We need the derivative. The derivative of this, we use quotient rule to find the derivative of this, which will give us, you derive the numerator first. Derive the numerator first. So we have 1 into s squared minus 1 minus x into 2x. Okay, all over s squared minus 1 square. Okay, let's quickly rewrite that. S squared minus 1 minus 2s squared all over s squared minus 1 all square. Okay, that will give us minus s squared minus 1 all over s squared minus 1 all square. Okay, that is the derivative. That is the derivative. Now we need to equate the derivative to 0. Equate the derivative to 0. Okay, so we're going to be having minus d square minus 1 all over s square minus 1 square equals to 0. This implies that minus s square minus 1 equals to 0. So minus s square equals to 1, s square equals to minus 1. Okay, so we have s square equals to minus 1. If you find the root, we are going to have plus or minus root of negative 1. Root of negative 1 is not a real root. It's a complex root. So not real root. Okay, because of that, we will not deal with this. So because we have the root of a negative. So anytime you have a root of a negative, you can't find it, at least for now. It's a complex root, but for your level, you can't find for now, so we can't go by this. So we don't have root when we equate the derivative to 0. So, but we need to find where the derivative will not exist. Okay, we need to find where the derivative will not exist. Okay, the derivative will not exist when this equals to 0. That will give us s squared equals to 1. Okay, this is positive 1, not negative 1 like this one. Okay, so that means this equals to plus or minus root of 1, which is plus or minus 1. Okay, so the derivative will not exist when s is minus 1 or plus 1. Okay, that is our critical value. So our critical values are x equals to negative 1 and 1. Okay, so we use that to make our intervals. So that means we are going to have negative to 1, negative infinity to negative 1, then 1, then positive infinity. Okay, so those are the root. Those are the values. So here is from negative infinity to negative 1, negative 1 to 1, 1 to positive infinity. So we want to test our derivative there and see which one will give us positive or which one will give us negative. Okay. All right, so within this range, if I pick -2, I pick -2 and I put it inside the derivative. This is the derivative. The derivative, okay, the derivative can be written as, let me write it again here, s squared plus 1 all over s squared minus 1 all square. Okay, that's there. So if you put that there, you are going to be getting negative. So within this range, the derivative is negative. That means it's decreasing. If you pick a range also here, 0, and you put it there, it will also give you a negative. Okay, so it's also decreasing. If you pick, let's pick 2 within this range and you put them, it will also give you a negative. So all are decreasing. So decreasing, the interval of decreasing is -infinity to 1, -1, -1 to 1, and 1 to positive. So no interval of increasing. No interval of increasing. Okay, no interval of increasing. Okay, okay, please take note of that. Now, what is the next question? They said we must find relative maximum or and relative minimum. Okay, so since there is no interval of increasing, we have no relative, the second one, no relative maximum or minimum. Okay, no relative maximum or minimum. Okay, please take note of that. Now the next thing is for us to find the interval where the function is concave up or concave down. Concave up or concave down. Okay, in order to find this, let's go to another new page. Okay, so now we need to find where it is concave up or concave down. Okay, the first derivative we have is this one, s squared minus 1 all over s squared minus 1 square. Okay, that's our first derivative that we have. So let's find the second derivative of this. Second derivative of this, we use quotient rule again. So we derive this, we get -2x, okay, multiplied by s squared minus 1 square minus, we write this one, and then we find the derivative of these 2 into s squared minus 1, 1, okay, then multiply by inside 2x. Okay, that's what we have. We have 2 minus 1, yes, then multiply by inside. Okay, that's fine. All over s squared minus 1 raised to power 4. Okay, let's tidy up. Then we have here, we have the same here. Okay, minus this one, minus, we can factorize minus out here to be positive, so this becomes s squared plus 1. This becomes okay, yes, that is fine. This now become 4x into s squared minus 1. Okay, that is fine, all over s squared minus 1 raised to power 4. Okay, that is fine. Let's check again. This come down. Yeah, this is fine. Yeah, that is okay. So let's now look for another one. So this one is there, s squared minus 1. I can also factorize one of these out. Then they will cancel this. So meaning I'm going to have s squared minus 1. Then this will be 2 minus this into s squared minus 1 plus this one will now be x squared plus 1 multiplied by 4x. Okay, that is what we have there. So all over then all over x squared minus 1 raised to power 4. So that will cancel one of these. That will cancel one of that. Then that will be giving us this will now be giving us 2x3 plus 2x, okay, then plus 4x3 plus 4x, okay, all over x squared minus 1 raised to power 3, okay, because this we cancel one of these. All right, so we now have there, what do we have up now? Any constant? No constant. So up now we have this becomes 2s3. This will become plus 6x. Yeah, that's fine. All over x squared minus 1, 3. Okay, that is what we have as our second derivative. Okay, don't forget, you must know how to derive properly. That's what we have as our second derivative. Now, in order to find the interval where it is concave up, concave down, we need to equate the second derivative to 0. This implies that equating this to 0, and then it implies that we have 2x3, not 2s3 plus 6x equals to 0. All right, so here we can factorize x out to be 2x squared plus 6. Yeah, in fact we can factorize 2x out, so that means we are going to be having x squared plus 3, okay, yeah, equals to 0. So we have 2x equals to 0, which implies s equals to 0, that is fine. Or we have s squared plus 3 equals to 0. This means s squared equals to negative 3. See, we are having negative on that side again. So that means s is equal to plus or minus root of negative 3. And as we said before, we cannot find it. This is a complex root. This is not a real root. So we are not going by this, but we have this s equals to 0 here. Okay, so that's fine, but the other thing we can have also is where the second derivative will not exist. So the second derivative will not exist. The second derivative will not exist when s squared minus 1 equals to 0. That is the denominator. That is you see, this is our second derivative. So when this equals to 0, then it will not exist. So we need to find that. That means s equals to plus or minus root of 1, which is also plus or minus 1. Okay, so the value we need to use here is s equals to 0, and then x equals to plus or negative 1. So that's what we need to find our interval. So the interval will be negative infinity to 1, negative 1 to 0, 0 to 1, and then 1 to positive infinity. So these are our intervals. Please remember that we don't use this one because this is a complex one. Okay, it's not a real root. Anytime you have the root of a negative, you are not to use that. It's a complex root. Okay, all right, so now let's find here where the second derivative will be greater than 0 or less than 0. Second derivative. So we want to find where the second derivative will be greater than 0 and where it will be less than 0. That's what we want to find. So if you pick a point, within this interval, pick a point here like a negative half. Pick a point here, half, pick a point here like 2 and put each of them in our second derivative. Let me write the second derivative again. We put each of them in our second derivative. So we have 2x3 plus 6x all over s squared minus 1 raised to power 3. Okay, we want to put each of them in our second derivative. So we discover that if you put negative 2 there, this will be giving us negative. Yes, this will give us negative. If you put this there, this will be give us positive. If you put this there, this will give us negative. If you put this there, this will be giving us positive. Okay, so here it means it is concave down. It is concave down. It is concave down. Here is concave down. Here is concave up. Here is concave down. Here is concave up. Okay, all right, that's nice one. Okay, concave. So we have concavity there. Okay, so our concave up interval of concave up is -1, 0 and 1 positive infinity, and the interval of concave down will be that one. So our concave down is -infinity to 1 and concave down and 0, 1. Okay, that is concave up, concave down. All right, now those are the interval. Now the point of inflection. Of course, concavity changes here, but don't forget -1 is not part of the domain of the function. It's not part of the domain of the function. The function that was given to us previously, yes, this function, x equals to plus or -1. S is not equals to plus or -1 in this function. So plus or -1 is not part of the domain of this function. Okay, so though concavity changes at -1, -1 is not a point of inflection. Okay, again, at 1, though concavity changes there, 1 is not a point of inflection. So, but at 0, concavity changes, and 0 is also part of the domain. So we have our point of inflection there. So the point of inflection, so the point of inflection is at x equals to 0. Okay, that's the point of inflection. Okay, please ensure you understand. Let's see if we have answered. Okay, yeah, we have answered all the questions. Please ensure that you understand. Please ensure you understand.